Good morning, everybody, or good afternoon, depending on where you are. Welcome to our webinar today. My name's Matthew Bourne, and today's webinar, guys, is about integrating infrared thermography into Machinery Health Manager. Guys, today I'm joined by, firstly, Adrian Smith, who's our lead trainer here at Alstom MSc, and one of our senior engineering staff here. How are you today, Adrian?
I'm very good, thank you. Morning, everyone.
Thanks for joining us. It's still morning here in Victoria, at least. And I'm also joined by Bret Jones, who is our Reliability Technologies Product Manager. How are you today, Bret?
Very well. Good morning, Matt, and good morning, everyone.
Now, Bret, if memory serves, now I know you turned 50 this year. Happy birthday for that. And I believe you've been doing infrared a while. So if I do my maths right, you probably first started out with a infrared camera that required a bit of liquid nitrogen to be poured in the back. Would that be right, Bret?
Oh, I don't think I'm that old.
You're not that old?
Not
sorry,
old,
mate.
no.
Apologies.
The first cameras that we were selling, they had the first FLIR cameras that we were selling. Actually, they had the Sterling cool detectors in them. They were very noisy. They rumbled around a bit, but they were very, very good cameras back then. That was probably 18 years ago.
Okay. Oh, Sterling compressors in cameras. Wow. Have to do VA on them. Anyway, that's vibration, guys, mate. We can never let it be. Anyway, let's get started, guys. I just want to talk to you very briefly about us, just in case you're not so familiar with us. We're part of the Alstom group, and Alstom has three main activities that they carry out in 4 sectors. We're involved firstly in thermal power and renewable power, which is the part of the business, thermal power that is, that we belong to. And then Alstom Grid, which is equipment and services for power transmission. And finally, Alstom Transport. Adrian, you've always heard my frustrations. Why don't the new trains in Melbourne look like that nice red machine?
That'd be nice, wouldn't it?
Oh, rather than those plain-looking silver ones. But they're very nice Alstom trains here in Melbourne, I should say. And guys, Alstom MSc, we've been around now for over 25 years, about 40 employees. We have a dedicated training centre here in Croydon, and a CM services team, and a large number of companies in the Australasian region who are utilising our products and services. And I guess what we see as our unique capability and what makes us strong is the fact that we do have the ability to provide services. We use the equipment that we sell. We understand how it works. So we provide services. We provide a range of leading products and brands. We provide training, and Adrian here with us today is one of our lead trainers, as I mentioned earlier. And in addition to that, we provide the customer support here as well on the products that we sell. So what I'll do is I'll hand over to Bret now, and I think, Bret, what you're going to cover for us a little bit initially here is some of the information and the criteria on selecting an infrared camera. Is that correct?
Thanks, Matt. Yeah, as before, I guess we get into some of the detail about the software side of things with the MHM infrared software that now is manufactured and complements the CSI suite of software. I guess one of the things that's really important is understanding with the thermal imaging cameras, how does someone go about finding a camera that is appropriate to their applications? And really, when it comes into it, it's really 3 words that I could sum it up in. It's really fit for purpose. So when I'm talking to a customer about thermal imaging, what I really want to do is I want to know what their application is, because if I can do that and understand the types of things that they're going to be trying to measure, to try and explore other applications that they may be able to use the camera for, then we can actually look at the specific camera specifications that are going to actually meet the application that they have. So we want to match that requirement of that application, find a suitable camera for them. And also with the selection of the cameras, we want to have a look at what are the right sort of features that the customer is going to require that's going to give them an economical choice to be able to do the work that they require. So there's some of the key things that we look for in trying to assist customers to identify the suitable cameras. In most applications, the thing that we look at that's quite important is resolution of the camera, and we'll talk about that a little bit later. Some of the other things that are very important as well might relate to spot size of the camera, some of the options that the camera will have in relation to measuring different temperature points. The sensitivity of the camera will be an important factor. The temperature range that the camera goes up to will obviously be important. And then the ease of use of being able to interpret the thermal image once we have one. And there's different ways we can do that. There's visual blending, there's some new edge line definition features, which you see on the picture there on the screen, which help to enhance the thermal image and almost provided a visual appearance. And then there's other factors like reporting convenience, and often a neglected thing is how do we actually store and manage the infrared images that we have, because often we can have thousands of these images, and it's where do we put them so that we can retrieve them and find them easily. So there's some important things that we need to look at when we're actually selecting a camera. So a couple of little bit of terminology here that might help some people. Some of the things that we talk about when we're discussing cameras, obviously with cameras we talk about field of view, which relates to the lens that's used. And field of view, that's actually what the camera actually sees. So you can see the picture to the right hand side there. There's a blue box, mentioned FOV. That's what the camera's actually seeing. But what we also need to understand is a thing called the instantaneous field of view, because this is what the pixel actually sees. So this is one detector element on that camera, and this is the thing that's doing the temperature measurement for us. So we usually talk about these things in milliradians, but if we understand the type of lens that we have on the camera, we can actually relate this back to millimeters at a certain distance, so we can start to understand the object size or the target size that we can actually hit with a particular type of camera. Another thing that we often talk about as well is the pixel resolution of the camera, whether we've got a 640 by 480 pixel camera, whether we've got a 320 by 240 or a 160 by 120. So the resolution will actually also assist us in determining whether we're going to be able to accurately measure something. And what we need to do, one of the things to remember, is we must have 3 pixels that are able to cover the object that we're measuring. Another thing that we often talk about is NETD, which is the noise equivalent temperature difference. And very simply what this refers to is the thermal sensitivity of the camera. And if we have a lower NETD, then you'll see the 2 comparative pics there. We will get less noise and a better image. So we generally look for cameras that are 100 millik or less, or 0.1 degrees C or less. And some of the cameras will go down as low as less than 0.05. So there's some of the things that we like to look for when we're choosing cameras. Obviously, the more pixels that we have with our camera allows us to more accurately measure temperature. So you can see there we've got 3 examples of the same pictures taken with 3 different cameras, a 160 by 120 format camera, a 320 by 240, and a high resolution 640 by 480, which has significantly more pixels. So once we're moving from a lower resolution camera up to a higher resolution camera, you can see there how the temperature accuracy of a fault at a distance is much more accurately obtained. So this is just an example here of why we actually need to actually have a resolution on the camera to suit the application.
That's very interesting, Brett. I hadn't understood that well, and it is quite a significant difference we're seeing there based on the resolution. And I can imagine people fooling themselves that the temperature was lower than it actually is.
Yeah, and often we get a situation where when we're talking to customers about thermal imaging and cameras, they might have some spot radiometers or some temperature guns on site, and they'll go and take a temperature reading, and they'll think that they'll measure a machine at 40 degrees and they'll think it's operating okay and there's no problems with that machine. But because of the fact that the camera has such large pixels that it's working off, they can actually be measuring the hot component, which might be 90 degrees, and also measuring the background temperature, which might be 20 degrees, and really what your temperature gun or spot radiometer is giving you is an average of those two. And so you walk away from the machine thinking there's no problem, but where in fact, in reality, if you had an appropriate camera with a reasonable resolution, you would have actually detected the 90-degree problem. So resolution is really important, and really we have to match cameras to particular applications. So this just gives us a bit of an idea that we could have a very high resolution camera to look at a particular object from a distance, and one picture might be all we need. But if we have a lower resolution camera, like a 320 by 240, we might need 4 pages of reports or 4 pictures to replicate the same sort of image. Or if we have down at a 160 by 120 format, then obviously we need a mosaic of a lot more images and closer in as well to be able to produce the same result. So resolution is a really important criteria when we're looking at selecting cameras. So I guess just a little bit of info about, I guess, Alstom MSc. Over the last 20 years, we've supplied cameras to industry. And if we go back 18, 20 years ago, we actually sold the FSI FLIR systems camera. We sold the Prism DS in our early years. And then the Agema brand, the Inframetrics brand, the FSI brand, the Indigo brand, they all combined together to produce a new company, FLIR. And FLIR essentially has been operating for over 50 years now. They're the global leaders in thermal imaging, the camera build quality, the image quality, the effectiveness of how these cameras measure faults is testimony to that. And where Alstom MSc is now also an authorised FLIR distributor as well. Just, I guess, a quick update on some of the cameras that FLIR actually sell, just to give people a bit of a bird's eye view. They have their early entry-level models, which are the I series, which are pretty much the tools that would be used by an electrician just to take quick checks on some switchboards close in. Those cameras come in at under $3,000. Then they move into their more professional range of cameras, the E series, and they range up to $12,000. And then they move into the professional range of cameras, the T4 series, and under $20,000. But then we go up into the T6 series, which are their high resolution 640 by 480 cameras, which are over $30,000. And obviously, as we go through the range of FLIR cameras, the features and benefits increase as we do that. So with the I series, I guess, if I just take a snapshot of the popular models, the i7, reasonable resolution, 140 by 140, a good little tool for a electrician to do close-in spot checks on switchboards, etc. And nice basic features on the camera to be able to do that. The next series, the E series, certainly the popular model there is the E60 with its 320 by 240 pixels. It provides hot seeking cursors, nice display, goes up to 650 degrees. It has a digital camera built in. Voice annotation. This camera can also do instant PDF report generation inside the camera, which is very good, and probably the best choice for someone who's looking for an all-round camera to do basic scanning in their plant in an economical manner. So.
And that one integrates with your iPads and your Android devices and
correct. So we can
and
bring some live images. So I could, for example, produce an instant PDF report in the camera. I could send that to my iPhone, that PDF report, and email it directly to someone on the spot to take immediate action for that fault. So there's some nice features in that camera.
No problem.
Then we move up into the T series, and one of the things that is a nice introduction when we get into these models is the MSX feature, which you can see on the picture there, and this is an edge line definition which actually enhances the thermal image, and it also allows you to see serial numbers on components. You'll have the visual image still that you've taken with the thermal, but this is just an added bit of information that you'll get with the thermal image. So I would always use the MSX feature on these particular cameras. The other advantage as we move into the T series is they have a tiltable lens, so we're able to view things and look at things at different angles, which is helpful as well. As we move up into the T600 series, we have a larger screen, a 4.3-inch touchscreen display. We can go out to higher temperatures. We've got the still the main features that are in that camera, but essentially it's a 640 by 480 pixel resolution that's differentiating these cameras. So they really are the professional series for thermal imaging. And I guess one of the things that we want to talk about today is the recent things with the introduction to of the FLIR compatibility with now version 5.5 and the CSI infrared software. There are some fluke cameras that will also be supported by this software, and it allows us to use the same MHM database as our vibration and our oil, or in some cases electricians can actually create their own database separately for cabinets, and so there's flexibility for them to do that as well.
And Bret, if I'm right, if customers already have, say, a network copy of Machinery Health Manager, they could just buy an MHM infrared seat, is that correct?
They could just add a seat onto that,
okay.
Yeah, or they could add a standalone copy onto their software as well. And I guess the key message that we want to get across to our customers today is really the fact that what this new software package does is address the concern that many of our customers have got, is what do I do with all these infrared images that I've got? How do I store them? Because they accumulate a lot over time, and this is, Emerson have really provided a solution to be able to do that.
Okay, no problem. What we'll do, guys, thanks for that, Bret, we're going to now have a look in a bit more detail at the Machinery Health Manager infrared analysis module. And I'm assuming most of you are comfortable with Machinery Health Manager. It's a multi-technology condition monitoring software platform, and infrared analysis, as we said there, is a new tool that's been added in relatively recently to MHM. So what we're going to do is I'm just going to change over to Adrian now, and Adrian is going to, he's got a live MHM copy there, and Adrian's going to take us in there and show us some usage of the MHM IR module. Thanks, Adrian. Over to you.
Morning, everyone. Just trying to rearrange my screen here for a second. There we go. That's better. All right. So the plan here is to assume that we've already got an existing vibration database with vibration points, and what we want to do is go and add in thermographic points to that existing database. So over here in my navigator view, I can see I've got a range of databases here, including one from a recent training course that I'll use as a demo. So I'll just drill down into this vibration database here, and we can see we've got normal vibration points, and there's spectral data, etc. But we want to add some thermographic points to this. So the first thing we're going to do is to go into database setup, and I'll show you how to set up points in there. But just before I do that, I'll just quickly switch over to the infrared analysis module, and I'll go into that same database, and we can see when I choose the same machine in the same area in the same database that there's currently no infrared points against that machine. Alright, so I'm going to head over to Tools and Set Up Communications and launch the database setup program for that database. I can go into the tree structure, and here's my machine hierarchy. So I've got an existing machine, existing vibration points. I need to enable the thermographic technology on this machine before I can add thermographic points or infrared points. So the first thing I'll do is select the machine, come over to Edit, and I can see I've got a list of technologies here. So periodic or vibration is already selected, and the third on the list there is thermography. So I'll select that and hit OK. So that's now enabled the thermography technology, and in addition to a tab related to the vibration technology, I've got a new thermography tab. So there's a few things here I can specify at the equipment level, such as whether the equipment is indoor or outdoor, and it's also possible, this is optional, but to specify what equipment category the machine falls into. For example, I might say this is some kind of electrical machine, hit OK. It might be, say, something like a distribution panel or a motor control center, so I'll specify that type, and that's the equipment level specified for this database. So I hit OK. Thermography is now enabled for this machine, and I can now add thermographic points to the existing vibration points. So the easiest way to do that is I select the equipment level, and over on the right hand side I've got a button called Add Branch, which will add a point to that machine. And by default, it's come up with a vibration, it's not a vibration screen, it's already chosen the thermography technology in this case. But if I wanted to change technologies, there's a button in the top right hand corner called Change Tech. So I'll just show you that. If I click on that button, I can choose between periodic or thermography. So obviously I'll just quickly change back to vibration. So there's the vibration. Go back to thermography. Alright, so I can see there that influences what is happening. Alright, so I define my thermography point, so I might call this point T01 and call it infrared point 1.
And Adrian, while you're typing that, if I didn't already have vibration points on this machine, if I was starting a new database, for example, and say I was using the wizard, then I could just turn on the infrared thermography right at the start there, and then that would put the points on for me automatically.
Correct, so that from the beginning the database would be enabled for thermography, yes.
No worries, thank you.
There's some other things you can fill out on this dialog box. I won't bore you with all the details, and I'll just move on because that's the minimum necessary, and I'll hit OK. So there is now my infrared point, excuse my incorrect capitalization, and that's it. So if I now close down database setup, and if I go into the infrared analysis program, I'll just refresh the tree to make sure that that is updated, and then drill down to that same area, that same machine. I can now see that I have a new infrared point added to that database, and it's visible. So the next step, once I've got my infrared point, is then to add infrared measurements to that point. So there's a few ways to achieve this. Depending on what camera you're using, you may connect the camera to your computer and download images to a folder on your desktop. So that can be done through data transfer by choosing the appropriate hardware from the list of connected devices. For example, I might choose other IAR device in this case, and that will open up a folder, and I can move thermographic images from the camera into that folder. And once my images are on my hard disk, I can go to the infrared point in the infrared analysis program, and I chose the blue flag icon on the toolbar, which is to add a new infrared measurement. And then I see this screen here where I've got the ability to add a thermal image and a visible light image. So I'll then choose Browse, and that will open up a folder on my hard disk where I have some thermographic images. So in this case it's on the desktop thermograms. And I might come along and choose, say, a visible image and its corresponding thermal image or thermogram. So just by selecting those images and clicking on OK, they are now being added into the infrared analysis program. Now I'll just refresh my tree so you can see that they have now appeared against the measurement point. So there's my measurement point. I have now an infrared image and a visible image, and I'll go to the event level so I can see this screen. Now one of the things you might choose to do at this point is to add some parameters. This is optional, but things like wind temperature, wind speed, ambient temperature, etc. I'll keep that brief and skip over that. So once our images are in, the next step would be to go and analyze those images. So I can click on Analyze, and it will take me to the IR event level, and I'm going to click on the infrared image to bring up the thermogram to full screen. Alright, once we're looking at our thermogram, any annotations that might have been made in the camera will become automatically visible. This one doesn't have much, it's got one spot meter enabled. Down the bottom of the thermogram there is a coloured bar. This is called the palette bar, and this is used to indicate the range of temperatures in the image. Now the default palette for the image is iron bow, and I'll just open up this palette toolbar just to show you that there are a range of palettes available. I won't go through all of those. If I go down to the palette bar and right click on the coloured region of the palette bar, I can now manipulate the colour range. I can either drag that left and right to change the mapping of colours to that image, or it is possible to expand or contract the range of temperatures. Now, I've got a number of images or a number of panels open on the right hand side of the screen here. So I'm just going to step through and show you some of the tools that are available for analysing a thermographic image. For example, one of the first things you might want to do is to enable the automatic hot and cold spots. So there's a little control here. I can choose hotspot, and that positions an automatic hotspot. So I've got a temperature 133, and that is pointing to the hottest pixel in that image. If I do the same thing with cold spot, I get an automatic cold spot, and likewise it is pointing to the coldest part of that image. There are some other ones, I won't go through all of these, but there's a center point and a center box as well. And I can also add my own spot meters at any point in the image. So there's one that's there by default already. So actually I might just initially delete that one. And then I'm going to add a new spot meter. So to do that, I'm going to right click on the image and come down to add spot meter. And that automatically adds a spot meter. I can move the label around, and I can also change the pixel or location in the image at which that is pointing at. So if I point over here, it will tell me what the temperature is at that location. So I'm just going to change something here. Under annotation properties, I can change that to show a temperature instead. So now when I move that point around, you can see that the temperature is changing. Another thing you might have noticed is as I move my cursor around the image, there is what's known as a cursor readout. So next to the cursor itself is a temperature value. So whatever location on the image, so there, that area is 96 or 130 on the hot part of that lube pump. Now, spot meters can be displayed in an area on the right hand side of the screen. So this one that I've just added, I need to change its properties here and say spot meter, and once I've made it a spot meter, it now appears under the spot meters panel, and there's the label T1 and the current temperature of 122. Alright, so that's spot meters. There's a few other things about that, but I won't go into the details. Now, other things you might like to do to a thermographic image is plot a profile across a certain region of the image. So I was adding a profile. So to do that, I right click on the image and choose add profile, and there's line or polyline. I'll just choose a simple and keep it a line. So it's added a line to the image, and I'm just going to now manipulate that line and position it over this lube motor. And in the top right hand corner of the screen there is a profiles panel, and there is an active thermogram there. So it's actually showing me the profile of temperatures along the length of that line. And if I move that to a different area of the screen, we can see that the profile of temperatures changes across that line. Alright, another, I'll just delete that to keep the screen simple. I can also add what's known as a region. Again, by right clicking the image, there are various shapes. I'll just keep it simple with a rectangle. You can manipulate the rectangle and position it where you want on the image. So maybe I'll put it right in the middle of the motor here.
Just a question, Adrian, while you're doing that. I noticed this is this image that you happen to pick just a degrees Fahrenheit one? Is that why we're seeing F?
Good question. I didn't really pay much attention to it.
No, that must be the case. Yep, all right.
So there's a region, and again there's a regions panel on the right hand side of the screen, and it gives me a histogram of the range of temperatures within that box. So it's in the middle of a hotspot at the moment. If I move it so it's overlapping a hot and a cold region, like so, I can see I've now got a range of temperatures in my histogram. Alright, so that's a region. So that probably gives you a rough idea of the kind of things we can do to an image. There are other things as well, but we might leave it at that.
That's probably okay, Adrian.
Yep.
Let's have a look at the reporting. Is that the next thing we can
Yep.
have a look at?
So let's say I've done some analysis on this image, and I'm ready to report it as a problem. One of the first things I might want to do is maybe attach some user notes. So there's a thing called a user note panel, and this is just basically a free text field, and I can add whatever comments I want. So I might say in this case, motor running hot, or whatever comment I want to make there in that user notes panel. The other thing I can do is I can go back to the infrared event, and at the infrared event level of the navigator there is an area known as the fault framework, and within this fault framework we can start to populate information that you might be familiar with from RBM view. So you can sort of think of it as a cut down version of an RBM view problem. So it's got an automatic date and time from the image. I can specify who the thermographer is. I can indicate the severity of the problem, so I might say unsatisfactory, and I can choose things like what type of component it is. So type in motor. I can make an observation, hot casing, and I can specify a fault. Motor fault or something to that effect. I can also add in recommended actions. Alright, so the other thing I might want to do is on the image itself, there are various annotations you can make. Apart from the thermographic analysis, you can add things like text notes. So I've just added a text note, and I can say lube motor and enter. So I've attached some text to that image as well, so that you can mark up areas and stuff. Alright, now the next step may be to use one of the built-in report types.
Yep, that sounds like a good idea.
So depending on what type of what level of the tree you're at, there are different report types. So I'm currently at an infrared image. In the toolbar there is something known as the report view. So there's a couple of ways to access reports. You can either right click on the tree or use the report viewer. So if I click the report viewer button, it automatically takes me to the image analysis report. If there are other report types available, they will be available in a drop-down list next to the report viewer. So here we have our thermographic image. The information that I provided in the fault framework is available next to the thermographic image. Any annotations or analysis I've done to the image is available on this same report. So for example, that region that I had attached is still visible in the report. There's some information about the camera details, the visible light image. In some reports you can choose to also include a reference thermographic image, or maybe a reference visible image. Now this report, I can either print it out, so there's a print button available there, so I won't actually print it, but there's a print dialog box. You can choose your page setup and your page layout, etc. I won't go through all of that. And what probably most people will do is they'll export it to a PDF. So I might just quickly do that. So I'll give it a name. So my report, and I'll just save that on my desktop as a PDF, and that should open up automatically. So there's my...
Just give that a sec to update the screen, Adrian.
It's just opened up. Actually, maybe it might not show that because I think I'm only showing... Oh no, here it comes. So that's my PDF version of that report. So,
and you've put your own company logo into the software as well, I assume, is that
yes,
right?
so I've already specified up in the top right-hand corner of that report, you can specify your own company logo. So I've already specified that. I'll show you where to configure that a bit later on if we've got time. But I'll close that report down now. So that's just one type of report. If I click on the visible image, there's also something known as a visible light image report. If I click at the infrared event level, there are some other report types available.
Just slow down a little bit, mate. There's a lot of screen updating going on, and there's just a bit of latency, so just take it a bit quieter.
No worries. All right, so at the infrared event level, there's two new reports available at this level. One known as the basic summary report, which we're currently looking at, and also one known as the detailed summary report. So the basic report that we're looking at the moment, it's an interactive report, so I can do things like collapse the tree and choose to only show various levels of the tree. There's some very basic information like the survey date, the fault framework information, some thumbnails of my thermographic and visible images. If we go to the detailed summary report, we'll get a slightly more detailed report as you'd expect. So now it includes larger images, the fault framework information, some of the environmental parameters that were available at the IR event level. And again, it's an interactive report that we can choose to collapse various parts of the tree.
And Adrian, that's again showing the whole database or just an area?
This is just looking at a specific event at the moment. So what I can do is, if I go further up the tree, I can go to the point level, the machine level. Now in this case, I don't have... Actually, let's go, say, into another database very quickly. I'll just show you, say, a machine that has multiple events, if I can find one here. No. Sorry, I'll open up another database just quickly.
So this will actually let us browse through the tree in a report kind of hierarchy. Is that what?
Yes, that's what I'm trying to get to.
Okay.
Here. So say here, if I choose the database level here and go generate area list report.
Okay.
I can choose specific areas within that database. So let's say training room, and it'll then bring up a summary of all the IR points, all the surveys for that whole area.
Okay, so at the top we're looking at training room, then we've got the equipment, and then whatever points with whatever images we've put against them.
Yep.
Okay.
So there I've just collapsed that to the equipment level, and I can drill down into a particular piece of equipment, and I can see all the surveys or points that are on that piece of equipment. This top one here...
Slowly.
This top one here has 1 point and 2 surveys. So I can, again, like collapse to the survey level. And if there are multiple points, you can see multiple points. So hopefully that gives you a flavour of what you can do there. Just go back to my original database. I think I covered all the reports there. So you can do those basic reports and detailed reports at every level of the tree. Now the next thing you might want to do is you want more than just a PDF report. You might want to include the information from your thermographic survey and combine it with information from vibration surveys or oil analysis reports if you're using OilView. So therefore you might want to write up this problem in RBM view. Now our tool for consolidating all our problems from all our different technologies. So if I choose the sorry, where am I? Where's my fault gone? So I'll choose, just choose a different database for a second here. So here I've got an infrared image, and I'll go to the infrared event level. When I'm at the event level, there is an option to create an RBM view problem directly from that event. So actually I might choose a different, because this one has more information. So I'll choose create RBM view problem, and it brings up this dialog box, as you can now see, and it's pre-populated.
Sorry to interrupt you, Adrian. Was that little button? Can you just do that again for us?
Sorry, I'll just
I
repeat
missed that.
All right, so when I'm selected the infrared event level, that's the blue flag level of the hierarchy.
Yep.
Next to the lighthouse icon, which launches RBM View, there's another button called Create RBM View Problem.
Same icon as vibration analysis has. Is it? Yes, okay, the gears and the pencils and all that stuff. Gotcha.
All right, so,
thanks, mate.
So that one next to the lighthouse, when you click on that, it opens up a dialog box, and you're now populating an RBM View problem. And one of the advantages of entering that fault framework information earlier at the event level is that it's automatically dragged that information into this RBM View problem. So I don't have to repeat what the severity, the part, the observation was.
So those equivalent fields that you already populated in the IR analysis tool have gone to the respective fields for the RBM View
Exactly,
problem.
yes.
Okay.
So you've already half filled out your RBM View problem.
Halfway there.
Yep.
Good, good.
So the only additional information I need to add is what the certainty of the problem is, such as I can say very likely. I can provide an extended description. So I'm not being very inventive here, but motor running hot, or whatever extra information I want to add. And I can also add attachments to that RBM View entry, just like as I can if I was using RBM View directly. For example, if I had a PDF file from a third party, and I actually happen to have a PDF report here because I created one earlier. So if I go to that, sorry, I have to choose PDF files, and I should have one here called My Report. So I select that and open that up. So you can see it's now attached My Report to that RBM View entry. And I can also choose to add other images directly from my analysis. So things like if there were spot meters or profiles or regions, typically you want to include the thermal image or visible light image. And you can also automatically include an image of that image analysis report, which is actually the same thing as the My Report that I've got here that I created earlier. So we'll double up a little bit here, but just to show you that that can be automatic. And I've finished my RBM View entry. Now I can either just hit OK and keep moving on and analyze other problems, or if I want to see what that looks like in RBM View, I'll just tick on the Launch RBM View and hit OK, and it will open up RBM View and show me that problem. So RBM View is opening up, and I can see here I've got a new problem, and there's the date, the person who created the problem, my definition of the problem. There's my text motor running hot. I've got some attachments, including the PDF report that I attached. So it's just opening up.
Just give that a sec. So you're okay. So now we're seeing the PDF report which you attached.
Yep. So that's part of the RBM View problem now.
Okay.
In addition, there are the images that I attached, so I can preview one of those. Now in this case the profiles, I think the only one I had was regions. Actually no. If I had spot meters or I had regions attached to the image, so there's my thermal image.
Okay.
And there should be a visible light image as well, so I'll just click on visible light image, and there's my visible light image.
All right, good.
And there's also an image of the image analysis report. So I've got it both ways at the moment. I've got it as an image, and I've also got it as a PDF report. So I've doubled up, but you can do it either way.
Okay, good. Can we ask a couple of questions before we wrap up?
Yep.
Yep. Was there some more you wanted to show us there on the reporting, Adrian?
That was pretty much it for the reporting. The only other thing I can show is just some of the preferences, like how you set up your company logo, if that's of interest.
Well, look, given the time, maybe, and there's a couple of questions for some folks
well,
here.
let's go through some questions.
I don't know the answer to these. You might know some of them. Can multiple images be transferred at once, or do they need to be dragged and dropped individually when we're assigning the images?
You need to assign your images one at a time. The only exception would be if you were using a route-based camera, like the CSI cameras, in which case the images are automatically assigned to points.
But for regular usage,
yes, it'll be one at a time. Yes.
Okay, no problem. There was a question about trending data points. My guess is we'd have to have a separate data point set up that would be entered as a keypad or something, or a manual data logging. There's no trending of points.
No.
From reading to reading.
No.
With what we've covered there.
It is possible to set up temperature points in the database.
Yes.
But from the thermographic image itself, there's no automatic trending.
No automatic trending. No problem. Okay, no problem. All right. I think they were the main things that we had there from people. And there was one more there. Is the survey date in the report, this is a tricky one, is the survey date in the report the default date from the image?
Now, I think I'd have to double check. I think the date that showed up earlier was actually the date at which I created the report, rather than the date from the image.
Okay, no problem. And Stephen asks, can we create a report with Vibe and Thermo in the one?
Yes, so in RBM view, you can, this is the problem entry I've got here is includes thermographic information, but I can add problems that are vibration problems. So I could, for example, say insert problem, and this new problem could be a vibration problem.
Okay.
And when you run a report out of RBM view, it will include all the technologies. So the problem entry for the thermographic problem and the problem entry for the vibration problem. And obviously you could do that with oil view as well.
Well, let me ask you this, Adrian. What if we were to put in a single problem, and that problem might be a bad bearing or a coupling issue or a lubrication, say it's a lubrication problem.
Yeah.
I could initially have, say, put my infrared image against that problem.
Yep.
I could then be in vibration analysis, and I could assign that spectrum or vibration data to the same problem.
Absolutely.
And I'd get them both on the same report.
Yes, so you'd have, say, an image of a spectrum, an image of an oil view trend, and a thermographic image within the same problem entry within RBM
All right.
view. Yes.
Very good. All right, no problem. And problem detail A reports using RBM view, Fritz just asked. So if we did something like a problem detail A, we could get all those those images that you just showed us.
Yep. So let's say,
is that the right case? Is that the right problem we're on now?
Let's say if I choose this one here.
Okay.
So this is, I just got to choose, make sure I'm in the right database and everything. So tools, reports, problem detail A.
So we're just using one of the off-the-shelf reports, not one we've customised here, are we?
Choose a problem entry here.
Okay.
And submit. That should just give me a report on that single problem entry.
Okay.
So that's thinking at the moment. and it's just opening up a problem detail A, and you can see that I've got my thermographic image in there as well. So the empty box on the left-hand side is the PDF
the PDF
report.
can't be seen there. Okay, okay. So that's where if we had a, for example, a vibration spectrum or an oil view trend or whatever,
Yes,
they could be
yes,
shown
all
in there as
there
well.
in the same
No problem.
problemmetry.
All right, no problem. All right, well, look, guys, we're just about at the top of the hour, so I'll just steal back control from you, Adrian, and we'll wrap up. What we'll do, though, guys, we'll stay on the line after the official 12 o'clock close, 12 o'clock Eastern Standard, that is. If there are more questions people want us to fire across. Well, guys, thanks for your attendance today, and certainly hope you've picked up some useful information. Firstly, about the selection of infrared cameras, and it is certainly a dynamic area technology-wise, and a lot's changing. And you've seen there some of the aspects Bret's talked about in the technical specifications you should be looking for, and some of the interesting things in particular that FLIR are doing, such as their advanced communications with things like iPads and Android devices being able to take reports or view screens directly, and then other things such as the I know Bret's favourite is that edge line definition, where you can take an infrared image and still pick out details like serial numbers and that kind of thing, which is great. So I hope you picked up some useful stuff there, and of course a big thanks to Adrian for showing us there how the infrared module sits in there integrated with your Machinery Health Manager. There are some good deals. Bret tells me we've got what on ex-demo units, is that right?
We turn over our demo equipment fairly regularly, so
Okay.
we have got an E60 and an i7 at the moment, so if someone was looking for a discounted price on an as-new...
Yeah, they've had a pretty
E60,
easy life, haven't they?
Absolutely,
yeah.
they're very gentle out of the case now and then, but
Okay.
Those are available if someone wants to contact me.
No problem, no problem. Okay, and of course, guys, any questions, if you'd like any details on anything we've talked about, you want to get some pricing or some tech sheets or whatever else, please let us know. So thanks very much, guys. Again, we'll wrap up the formal part of the presentation here. So thanks again, and we'll let you go now. Bye-bye.